all you need to worry about is called logs, guys. I am not going to worry about spelling because Lord knows I will spell it wrong half the time. Anyway, so what we're talking about here today are stuff called logarithms. And we've actually used them back in our first section when we did sequences and series. There was one problem that you had to use a logarithm to solve for x. When we did that, it looked a little bit like this. If you remember, we had, I don't know, let's say it was 3 to some power was 6. All right? Now, think about what this is looking like. We know that 3 squared is how much? And 3 to the 3rd power is how much? So let's say, what's 3 to what power is 16? I'll put it in between the two. How would you figure that out? It's 2-ish, yes. 3 to the 2-ish. Well, to get a more approximate than 2-ish, what would happen here is we use these properties of what are called bases and exponents to solve this. When we did this back in that first unit, when you guys had to solve for the variable in the numerator, or not the numerator, in the exponent, I told you guys to take the log base of the same base of that exponent. You vaguely remember that? Yeah. And then that caused the exponent to fall. And then you did the same thing to both sides to keep it balanced. So this log works with the relationship between what are called bases and exponents. That's all it is. All the stuff that we've worked on with exponent rules, whether they're fractional exponents, negative exponents, integer values, or whatnot, they all come back into play with this stuff. And you're going to see it's relatively simple because the setup is the same. All right. Now, we did this one before where you would set it up and you'd press a button on your calculator, it would make it work. Today, what we're going to focus on more is going to be the stuff that you're going to be able to do by hand off the top of your head. So let's define logs. Log of base b of y equals x. That's how your book defines it out and how they write it out. That's called logarithmic form. I can't know. Let's say log form. Okay. The inverse of log form is exponential form. I don't want to say inverse, I should say it as the same way of writing it out is this. They're synonymous with one another. B to the x is y. And this is called exponential form. I was going to say expo form. And we flip back and forth between these two forms within each problem. What I want you to see here is that this base and that base will always be the same. Okay? The log of base b, b to the x, that's your base, and that's your exponent. So when we write them out, bless you, when we write them out in terms of like an actual problem, it'll look like this. Log base 3 of x. I don't know. I'm trying to think of one that works. Well, let's do a real example. Let's write it like this for right now. So if it's log base 3 of x equals y, I want you to see that these x's and y's don't necessarily mean that they're always going to be a y and an x in that order. It's just some variable, right? It's just some value. If I want to write that in terms of an exponent, it would just be 3 to the y is x. That's how you switch them back and forth. It's just quick back and forth like that. All right? There are a couple of very easy properties that we use right off the bat with these. For example, log base b of y is x. Therefore, b to the x is y. What happens here are these two very simple properties that work, that we're going to use a lot of. Think of it this way. Log of base b of 1 is 0. And the reason that is because what's anything to the 0 power? 1. In terms of a numerical example then, if I say log base 2 of 1, that's asking you 2 to what power is 1? 0. That means 2 to what power is 1? Well, that has to be 0. That's what the property says. That's how these bases and exponents work back and forth with one another. Right. Same idea when you're saying that log base b of b is 1. What that is saying is b to the first power is b. Because what is anything to the first power? Itself. Numerical example, let's say log base 6 of 6. Are those two numbers the same? Yeah. When those two numbers are the same, that means 6 to what power is 6? 1. That's what that means. The relationship between the bases and their exponents. What's up, Claire?
I just don't get where the numbers go.
What do you mean? Which?
Why does the base b become wait, what? Why does base b become, wait, I don't get this. This is confusing. Sheldon, look at that.
Remember what's happening here. This base here and this base here, they're going to be the same because the base on the right has an exponent, base and exponent. The base on the left is the base of the logarithm. The logarithm base and the base of the exponent will be the same. Does that clear it up a little bit? It just looks weird because it's the letter B in both places, I think. You'll have to trust me, Clay, because it does get cleaner. All right? You'll have to trust me on this. And I think you'll probably see it this next week. All right? Let me show you this. What I want to do here is go through with you guys in a couple of these of how you can switch between log form and exponential form. And this is usually when people start to pick up on, oh, that's what it's doing. So if the first one is the log base 2 of 32 is 5. That's saying 2 to what power? 2 to the 5th power is 32. It's saying that. Remember your equivalencies here. Log base b of y is x. B to the x is y. What Claire brought up in 6-7 was that you'll notice, see how this 5 is just going to the exponent here? And the 32 comes out this way? 2 to the 5th power is 32. What she notices is that if you just flip-flop them, you're getting your exponent form. You see that? Take a look again. Log base 5 of 1 is 0. What would that be then in exponential form? 5 to the 0 is 1. What's that? No, go ahead, say it.
Really fast.
See how it's just moving this over here and this is coming forward? And the 1 is switching out to the other side? You see how that pattern is evolving?
Okay, I just switch. sub exponent. Now it's I up to the base.
The base.
Shut up. He said the next time you say that, he's gonna slap you.
Log base 10 of 10. Log base 10 of 10 is 1. 10 to the first power is 10. This reminds me real quick of how these bases and stuff come about. There is what we call a standard log base. A standard log base is base 10. So your standard log base, if you don't see a number there, is always 10. So in this case, see how there's no number out under by the G? That is implying that it is log base 10 of 5. Everything else will always have some numerical value. Bless you. It'll say log base 3, log base 5, something like that. But if there is no number there, it is automatically assumed that it's base 10. Just like the coefficient in front of x is always 1. Does that make sense? It's one of those rules that they just don't write. Now, it goes into the thing with your calculator. On your calculator, there's a button that says log. If you press the log button, it's automatically base 10. This is how you count.
No, it doesn't.
Well, we go by tens. Now, if you go to the other one, there's another form of doing this as well. If you hit alpha window, option 5, you can change your log base. Okay? So the difference here is, if it tells you some numerical value for your log base that's not 10, you hit the alpha button. If it is just log, you can hit the log button. Okay? There will be ways for us to change the base with just the log button if we want to later on. But now, since calculators have caught up to the real world, we don't really need to do that very often. All right. Just wanted to show you that real fast because it does show up every once in a while that they don't put that 10 there, so you have to assume that it's a log, it's a base 10.
Oh, okay. This
We okay on that?
like a log 232. Where does the It's nice.
But what they will do is they will switch some stuff around on you and write things in terms of decimals. So now you have log base 10 of 0.1 equals -1. How would you rewrite that? 10 to the -1. Well, is it 10 to the -1? 110? Which is 0.1. They will do this to you pretty regularly when they're talking about decimals and into fractions. They will switch between the two pretty often. Okay? Why? Because they like to annoy you. Even more so than I do. They do. Those freaking math nerds, I tell you.
Who's they?
I don't know, beggars. Log base 1/2 of 2 is -1. Log base 1/2 of 2 is -1. That would be 1/2 to what power? 1/2 to the -1 power. It doesn't, when you have a negative exponent, don't you just flip your fraction? You will see that often, where you're switching between fractions and whole numbers, or from whole numbers to fractions. You're probably playing around with negative exponents at that point, because that's how you flip fractions. That's how you flip between them, okay? You'll see that a lot. I just say these out loud without having to write them all out. If I have log base 3 of 9 is 2, what would that be in exponential form? 3 squared is 9. Log base 5 of 5 is 1. 5 to the first power is? I want to write out this one just so you see how this is going. 1/2 to the -2. Flip your fraction and square it. That's where that comes from, using your exponents. And then lastly, 19 to what power is 1?
0.
0. Because anything to the 0 power is 1. You'll start hearing me ask you more and more about what to something power gives you this. It's a lot of mental math. It's not going to be that difficult stuff that you're not going to be able to figure out on your own. Okay? For example, if I want to figure out this, solve for x. This is log base 9 of x is 1/2. Well, I can't really solve it when it's sitting like this, but if I rewrite it into exponential form,
9 to the 1/2 equals x.
9 to the 1/2 is x. What is the 1/2 power mean? Square root. What's the square root of 9? See how you're able to set up the problem without using your calculator, because you won't be using calculators on these. There will be a time when you will have to use a calculator, but for stuff like this, you won't be using your calculator.
Have you set a date for our test and stuff?
We have a long way to go. We have a long way to go before we're
Yeah,
done.
it's great. Lovely.
So what we're going to do here is figure out these without using our calculators.
Does that mean it equals x?
Yes, think of it that way.
Okay.
So what I'm saying here is log base 3 of 81. What that is asking you is 3 to what power is 81?
4.
4. So what's 3 squared?
27.
All right, what's 3 squared?
9.
What's 9 times 9?
81.
Wasn't a trick question. So this has to equal 4. Because you're asking yourself, 3 to what power gets you 81?
Can I look at it as like
No, because it's not the third root of 81. The third root of 81 won't be 4. Think of it this way.
I don't like this. I don't like this.
Put your x value here, and then just rewrite. 3 to what power is 81? And then you just have to sit there and think, all right, 81 is a base 3. Okay. Log base 5 of 0.04. It's got to be negative. What is 0.04 as a fraction? It's 1/25th, isn't it? Because this is 4 over 100, so it's 5 to what power? It's going to give you 1/25th. It's -2. Because you're squaring it by multiplying it out. Now, this is another example. I went from integer, and I got to go to fraction. When I go from integer to fraction, what does my exponent have to be? It's got to be negative. That's how you flip it. So it's got to be negative. And since the rule to get from 5 to 25 is I'm squaring it, that means my value of x is -2.
Are we gonna die?
Okay? Oh, I didn't realize I had that on there. Good morning. I put a sound effect down there. I forgot that I put that there. To go from 5 to turn it into a fraction, you have to flip it so you have the -2. Okay? Because you're asking yourself, 5 to what power is 1/25? 1/2 to what power is 8? -3, very good. And the reason is because you have to flip the fraction.
Flip the fraction. Wait.
Wow. Okay, everybody see how you have to flip the fraction? We all know that 2 cubed is? So this has to be a -3. And then lastly, 9 to what power is 3?
-1/3.
9 to what power is 3? 9 to the 1/2 is 3. Oops. Because the 1/2 power means square root. Okay? It takes a little bit of time because you have to sit there and think about what is the exponent doing? What is the value working through? This question, when you're doing these, is what you're asking. You're asking yourself that over and over again. Okay? And it's not terrible. It just takes a little bit of getting used to.
It's a little.
It's a smidge.
It just takes a little bit.
What I have here is some little guided notes / examples, so you don't have to continuously write them out over and over again. Okay. And what I want to do is take a couple of minutes and give you guys some time to try some of these on your own. Yeah. Now on this sheet, on this sheet, guys, go to the second page, and I want you to do those in the middle. You're rewriting from logarithmic to exponential. You're going from exponential to logarithmic, and the last ones you're trying to solve on your own. Don't use your calculator. Do you know what? Nope. All you're doing is, you send that one back with this. All you're doing is just rewriting it. So take a couple of minutes, and let's try it. Nope, you're not solving. The only part you're solving is that last one, because it says solve. The other one says rewrite. All right, let's go through a few of these. I'm assuming that the first groupings are always pretty simple, because we just did all of these. So log base 3 of x is 9.
No, 3 to the 9.
3 to the 9th is x. Yep. We're not trying to solve it.
Wait, we're supposed to, gosh.
All we're doing is just rewriting it.
I thought you said the middle, so I thought the middle meant number 2.
I'll go to that one if you want. We already did a whole bunch of the rewrites to the exponential form, so I'm guessing you guys are okay at the exponential. We just did a whole ton of them. Let's look at the ones in the middle. So these are your b to the x equals y, which means you wanted to make it look like log base b of x is y. Oops, sorry, of y is x. Okay? Those are your equivalent forms. So the first one is 3 to the 4th power. So that means it's log base 3.
3 to the y equals 4.
You log base 3.
Y equals 4.
Okay? Does that make sense? We're just following the pattern. Next one you have log base 3 again.
27.
There you go. What's that?
I wrote it down right too.
Your hand's just not working correctly.
No, I wrote it down right. I just didn't say it right. Here's where.
Yes, ma'am.
Last chapter.
Log
Your
base
last
4 and equals 2.
Are you okay going to exponential form then?
Yes.
All right.
It's like you're so 2000 and late. Your last chapter.
It's big. It's having its one. So when you're starting to solve these out, this is asking you
3 to the 4.
3 to the 4th power is x. What's 3 to the 4?
81.
81. Next one is m to the 4th power is 81.
3.
What's M?
3.
3. The next one, log base something of 1,000 is 3.
10.
10. All right.
Right, so,
Ooh, hold on, I'll go back.
what
Sorry.
was C?
What's that?
What was C again, like?
10. Because this is x cubed is 1,000. Okay? That's how we're rewriting that before. You don't have to do plus minuses in these. You don't have to do that ever. Oh, you wouldn't have to do it with the cube root, but any of the squares or even powers, you don't do plus minuses on these. We're all okay.
Oh, sweet. Just the kind of math I
All right. 2 to the 5th power is x over 2.
So,
What's 2 to the 5th? So 32 equals x over 2. What's x?
16.
You don't divide with a fraction, but
No, because you undo that by multiplying. So this becomes 2 to the 6, which is 64.
that's why you get 64, not 16.
Okay. Next one we have y, 3 to the 5th is y. Well, 3 to the 4th was 81, so what's 3 to the 5th? 243.
43.
Okay. And then lastly, 2 to the 5th is 4x. 32 equals 4x, and it is? Good.
I couldn't divide 32 by 4. She had to use my calculator. I couldn't do it.
Shame.
It's been a long day.
Shame.
It's been a long day.
Okay. Now, the next little bit is when we start to work with what are called inverses. And this is kind of how things get undone, if you will. What I want to look at here is how these inverses work. I'm not worried about the top part. Not so much. Okay? Now, in order to undo one another between logs and exponential forms, there's a certain rules that have to happen. For example, if I wanted to undo a log, it's log base 3 of x. If I needed to undo that to get x alone, I'd have to make this cap. I'd have to exponentiate it.
Doesn't
What-
sound like a real word.
I don't think it's a real word, but it makes sense when you see what I'm doing here. Now, right here, to start out with, this was a log base 3. Do you agree?
Yes.
Okay. Now, the 3 here is its own base with an exponent that has the same base. You see that?
So it's base 3 log base 3. X.
Correct. These two values,
You just get log x.
no, it undoes the log. You just get x. These two values here are the same base. Right? One of them is the base of the log, the other is the base of the exponent. In order for these things to undo one another, that occurs. When that occurs, that x value just drops. And it simplifies out to equal x. Right? That's how you undo one another. If you think back to when we've done this, we did this when we had 3 to the x power was 6. We had to take the log base of both sides. It's the same process. Okay? Here, we're exponentiating. Yes, sir?
Is it like a ratio thing if it was like base 3 log base 6 x? Would that be like 2x?
No. It's close to what you're thinking. I've got something I think that leads to what you're thinking, but it's not a ratio. It has to do with the exponents. All right,
Okay.
you're going to see something here real quick. I think I know exactly what you're looking at.
Do it right there, Shelly. You're ahead of the game.
Now, going the other way, if I have 4 to the x power, that's an exponential form, and I want to get that variable of the exponent to drop. Well, what's the base of that problem? 4. That means I have to log base it. So now I have the log base 4 of 4. Again, these two values are both bases in and of themselves, and they undo one another. And what are you left with? You're left with x. What we're doing here, guys, is we're trying to have the same basis, whether it's working exponentiating by putting it up, or just taking the log base of both of them. Yes, sir?
Wasn't sequences and series like chapter 5?
That was actually it's chapter 11.
Oh, so that's okay.
That's why we started out. Yeah.
Okay, that's why. Okay.
Yeah. So, and like I said earlier this year, you guys were kind of like the guinea pig of starting in that unit. Guess what? We're not starting in next year. That unit.
That was harder.
All right. Now,
So I feel like that, any questions relating to that on the finance review?
I have this graphic quadratic
okay.
equations.
Let me show you this then. What this is going to allow us to be able to do is simplify expressions. Again, so this is kind of where you're going with, I think.
Yeah, kind of.
Now, if you notice here, I have 10 to the log of 2.
Yeah, I was saying, would that be like 5x or something?
It's in an almost, but you're not multiplying it by 5s or anything like that. You're working with the exponents. What's the base of that log that you just don't see? It's 10. So do these two have the same bases?
Yep.
So since they have the same bases, what's your simplification then? 2. They have the same base. See how this is a base? If they're the same, it just drops. Okay. Now what's different in the next one is that they're not the same right off the bat, are they? But can I change the 9 into a base 3? How?
Divide by 3.
No.
Inverse log.
No. How can I rewrite 9 to have a base of a 3? No. 3 squared. Isn't this the same as log base 3 of 3 squared? Is it 9 3 squared?
Yeah.
Do they now have the same base?
Yeah.
Do they have the same base? They're both base 3, aren't they?
But they're different heights.
No, but they're still bases, aren't they? This is a, remember, I want you to get over this. This is a log base, and this is the exponent's base. Are they the same?
Yes.
What's your answer?
Yeah.
This is what you were thinking.
Yeah, kind of.
What's happening here is that you have to rewrite it in terms of your exponents, not factors.
Okay.
Okay? Does that make more sense?
Yeah, it does.
That's where I think you were thinking. Now it'll work. All right? I'll show you another one before we run out too much time on this.
Run out of too much time.
Yeah. So this first one I have log base 2 of 64. I want to figure that out without using my calculator because I will not let you use calculators for this stuff. Well, it's 2 to what power is 64? That's what you're asking yourself. 2 to what power is 64? So if you rewrite it out in terms of base 2, that's 2 to the, is it the 6th? Yes. See how they're the same base? So it simplifies out to equal 6. Wowie zowie is correct. All right. Log base 25 of 5. Log base 25 of 5. Now, what can you do? That means it's 25 to what power is 5? 1/2. Okay? So you can play around with it because it's getting smaller. It probably means you had to take a root of it. Log base 6 is 1.
6. To get 1 to be 6, right? It's gotta be 6. and then
No.
it's
It'd be 0.
Remember, it's asking 6 to what power is 1? 0. It's going to blend back and forth into some of these. All right. 10 to the log of 4. 4. And the reason that just becomes 4 is The invisible 10. Gotta watch out for that invisible 10 that jumps out.
Standard base.
Standard base. Look at you. Paying
Legal
attention
term
today,
is
crazy like that.
finally learned.
There is a lot of stuff that we do. So, there's a lot of stuff that we do with logs. We will probably be working out of 8.4. Today and tomorrow, we're going to finish out working into inverses tomorrow. We're going to start graphing tomorrow. By the time we get into Thursday, that means we'll start with our log rules. There's condensing and expanding of logs. Because when wood gets wet, it expands. Did you know that?
Yeah.
You're hilarious.
All right, so here's what we got. This is 8.4. I want you, it's on page something or another. Please. I think it's 490. Yeah. Do those, please. All right. Oh, yeah. My wife and my friends. I've never seen them before. They've never seen them. And they were absolutely.
Oh my God, did you see the little girl that was dressed in this white?
It was so cute. And then the kids, there was a boy that had there was a boy that had a suit on.
It was so cute.
It was.
So happy.
I think our oldest son probably would have really enjoyed it, but obviously our youngest one would have been too much for him. But yeah, that was really cute.
We weren't expecting so many kids to show up. Like,
I thought that was nice of him to say keep it clean.
yeah, we know how to do